All right, so you're welcome to this class. Okay, so what we want to look at today is what we call electrostatics. So in the previous class, I finished capacitor. All right, we have done the whole of capacitor. So we want to look at what is the concept behind electrostatics or static electricity. All right, it is the same thing, static electricity. Now, the idea of what static electricity is the study of charges at rest, right? It's the study of what charges at rest, and that is what they tag as a course code to be is 152. Okay. Now, let's look at the concept behind charges at rest. Now, when you talk about charges, I've said in the first video that charges has a symbol Q, and they define it basically as the rate of flow. All right, the rate of flow of electric current. That is what charge is. Charge is the rate of flow of what electric current, and it's now in coulomb, right? So your Q is equal to IT from electrolysis, current multiplied by time, and the likes. Okay. When you come to static electricity, you are talking about the study of charges at rest. So let's see the concept behind that. So here we are going to be seeing electric intensity. We are going to be seeing the Coulomb's law. All right. We are going to be seeing the electric potential, electric intensity, the work done. All right. We see the flux, all right, and we see Gauss law. All of the things I've mentioned is what encompasses the whole of electrostatics. So if you can understand that all of those factors I've mentioned, then you are good to go in electrostatics. So now let's first of all look at charges. When you're talking about charges, when you have ebonite rod, for instance, ebonite rod, and you rub it with a fork, okay, you find out that at the end of the day, some negatively charged, all right, moves from the what from the fork and to the rod, all right, and at the end of the whole thing, there will be equal numbers of negatively charged and positively charged. Now, that is a particular way we can induce a charge, all right, because there are three ways we can charge, all right. There are three ways we can charge. We can charge by friction. We can charge an object by friction. We can charge by contact. And we can charge by induction. These are the three ways we can charge. So, what is charging by friction? Charging by friction is charging by rubbing one body to another body. All right. So, when you rub one body to another body, we are actually charging by a friction. All right. It is, or you can say, is defined as the method of charging in which two bodies are rubbed with each other. That is charging by friction. Okay. Then for contact is when you is actually a method of charging when a charged conductor share its charge with an uncharged conductor. So in friction we are rubbing. In charging by contact, all right, we have two objects. There's the charged conductor and there's the what uncharged conductor. All right. So when you bring it in contact with each other, the uncharged conductor becomes uncharged. In other words, you can call this neutral. That's what we call charging by what? By contact. Then there is charging by induction. Charging by induction is actually the method of charging a neutral body, all right, or an uncharged body by bringing the charged conductor, not in contact now, close, all right. Yeah, that's what we call an induced current, all right. You're inducing a charge on what? On the uncharged body. So this one is by rubbing. This one is by bringing the charged body to an uncharged body. And the last one is by bringing the charged body close, not in contact now, close to what? An uncharged body. And charges is induced on the what? On the neutral substance. So, what are the applications of electrostatics? I said electrostatics or studying electricity is the study of charges, all right, or electricity at rest. Then, what are the applications? We use it in dust extraction and we use it in electrostatic spray painting. Okay. Now, let us look at the law, all right, that is a major law. One of the major laws we use in electrostatics. The law is called Coulomb's law, and Coulomb's law was actually derived in 1875. Coulomb's law was derived in what? In 1875. What is Coulomb's law, and what is the whole idea behind Coulomb's law? So I'll explain. Coulomb's law actually states that the force of attraction or repulsion, all right, between two different charges, Q1 and Q2, because I told us that we are studying charges. The force of Coulomb's law states that the force of attraction between or repulsion between two charges Q1 and Q2, all right, is directly proportional to the product of the two charges and inversely proportional to the square of the distance. So that That is what Coulomb's law states. Okay, so we have the force of attraction or repulsion according to Coulomb's law is directly proportional to the what? The product of the two charges Q1 and Q2, and inversely, that same force is inversely proportional to the what? To the square of the what? Of the distance. And your distance in the context is r. R is equal to distance. So distance is equal to the value of r. So if this is the case, now in mathematics, there's what we call joint variation. So when you have two different varies, F is varying according to Coulomb's law, all right, in 1875, to be the, it's very nice to be the product of the two charges and inversely to the square of the distance. So what's going to happen if we combine them together is that we're going to be having your force is proportional to Q1, Q2, and it's also proportional to 1 over what? 1 over r squared. So what we have force now, all right, to be proportional to Q1, Q2, then everything over what? Over r squared. Your force is in Newton. So I will introduce a constant, all right. So we have F is equal to, if I bring the constant because of this motion, so I have Q1, Q2 over r squared. So at the end, I have my force of attraction or repulsion to be K, Q1, Q2 over what? R squared. But my K is equal to 1 over 4 pi permittivity, all right, 1 over 4 pi E naught. This E naught is what we call permittivity of free space. I've done one of those things before in the past, you can watch the video. K is equal to 1 over 4 pi E naught. So what is E naught? I told us that we have three kinds of permittivity. We have relative permittivity, we have absolute permittivity, and we have permittivity of free space. So permittivity of free space is given to be E naught is equal to 8.85 times 10 raised to the power minus 12 farad. Okay, so that is that. So if you want to impute the value of your constant in that equation, what are we going to be having? We are going to be having your force of attraction or repulsion between the two charges, all right? Now, your case now of 1 over 4 pi, so I have 1 over 4 pi permittivity, all right? Then open bracket, what is left? That is K1, Q2 over r squared. This one is going to be the force at the end of the day. But my value of K actually has a particular magnitude, okay? K has a particular magnitude, and K is given to be 9.0 times 10 raised to the minus 19. Okay, this value of the whole of K, which is 1 over 4 pi E naught, all right, is given to be 9.0 times 10 raised to the power minus what? Minus 19. Then the SI unit is in Newton. All right, Newton. I think we have it as Newton Coulomb per meter square, but we can check that. That is 9.0 times 10 raised to the minus 19 to be what? The SI unit of the what? Of the K. So I'll find K. So to know what exactly SI unit holds for it. All right. So if that's the case, okay. So I can say that my F that is equal to K into Q1, Q2 over R squared can now be written as F is equal to 9.0 times 10 raised to the power minus 19 into Q1, all right, Q2 over R squared. So let's go and find the exact value of K. So what is K? Now, what is my F? F is equal to what? Q over what? We have QQ, all right, KQQ over R squared. So if my R is coming to this side, so what do I have? This over 1. So I have F over 1 is equal to KQ1, Q2 over R squared. Okay, if I cross multiply, so I have FR squared is equal to KQ1, Q2. Okay, so if that's the case, I'm looking for the value of K. So I'll divide both sides by Q1, Q2. So I have FR raised to power 2, all right, over what? Q1, Q2 is equal to Q1, Q2. Then this also over Q1, Q2. So this one will cancel this one, then this cancel this. Then what is left? FR squared over Q1, Q2. Then everything is equal to K. Or K is equal to FR squared over Q1 over Q2 over Q1, Q2. So if that's the case now, let us find the SI unit. Of course, we know that force is measured in Newton. Okay. Then what is the value of the K? That is constant. Then that's what we want to find. What is our K? K is equal to what? FR squared over what? Over Q1, Q2. So my value of K, what is your force? Force measured in Newton. So I have what? Newton here. What is radius measured in? That is meter squared over what is charge? Charge is Coulomb multiplied by another Coulomb. Alright. So at the end, I'm going to be having Newton times meter squared will give me Newton meter squared over Coulomb times Coulomb will give me Coulomb squared. So I have the value of K to measure the Newton meter squared per Coulomb squared. Alright. So K is measured in what? Newton meter squared per Coulomb squared. Anytime you have to calculate for it. Okay, and it has an equivalent value of 9.0 times 10 raised to the power minus 19 Coulomb. That is that. So don't forget that I said we have three kinds of permittivity. Now we have absolute permittivity, we have relative permittivity, and we have the permittivity of free space. And the equation that connects all the three permittivity together, of course, we know that our duty of free space is given to be 8.85 times 10 raised to the power minus 12 farad. Okay. Now I told us the other time, all right, if you want